Hello everyone, welcome to an algebra recording, learning about the definition of a factor. This is the first video in a series about factoring polynomials. To start with, I just want to go over what is a factor. If we're going to do all this heavy-duty factoring, it seems like we need a good base foundation of what it is we're actually doing. So here I've got a definition for us to look at and to think about, and we're going to go over a few examples about factoring. So a factor, or when we talk about factoring something in mathematics, it's to write a number or expression as smaller numbers or expressions multiplied together. So we're rewriting something in a different form. We're rewriting it, kind of expanded out in a bunch of little things all multiplied together. So let's take a look at a number 18. This is pretty familiar to us, right? I already kind of know, and you probably already know as well, 18 I can rewrite as 6 times 3. Well, the 6 and the 3 can each be called factors of 18. So 6 is a factor, and 3 is also a factor. And because I've expanded it out, it's an expression of smaller numbers. 6 and 3 are both smaller than 18, and multiplied together they make 18. I could continue to expand that out. So 6 times 3, I could go even one step more and say, well, 6 can factor out into 2 times 3 times 3. And so now I've split 18 up into 3 factors. I've fully expanded it out all the way. I can't do it anymore because 2, 3, and 3, there are no smaller numbers that are factors of those. And I can rewrite different factors. So 6 times 3 also worked, but what about 2 times 9? So there's different ways to factor things out, different factors, and we can kind of get it all the way out there. All right, so there's a quick, easy example of taking a number and factoring into smaller numbers multiplied together. What about when we throw some algebra in it? What about 8 times x squared? How do I factor that? Well, again, I just need to rewrite it as smaller numbers or expressions multiplied together. So one way to write this is to say, okay, well, write it as, oops, I don't like that color. Let's go back to purple. Let's be consistent here. Let's go write it as 8 times x squared. That's factored out. That's separating the number portion from the variable. So 8 is a factor and x squared is a factor. I can continue to split that even more. 8 is the same as 2 times 4. X, I could rewrite as x times x. The x squared right there just means I have 2 x's. Well, now I've factored it into 4 things, right? 2 times 4 times x times x. These are all factors of the expression 8x squared. And I could even go one step more. 4, I could rewrite it as 2 times 2 times 2 times x times x. And that's about as far as I can go. 2 is a prime number. I can't factor it anymore, and I can't factor the x down. But I can get combinations of this now, right? So those are all factors. Those are all different ways of rewriting 8x squared into smaller factors. And I could have some fun with this. I could say 8x squared, okay, that's the same as 4 times x. Let's separate that out. 4x would be a factor of 8x squared. It's a smaller expression. And I can multiply that by 2x. So again, I've taken 8x squared and I've factored it into 2 things. So it's not as far as I could factor, but it's still an expression that is split into 2 smaller expressions multiplied together. So here we go. Again, different ways, different factors. X squared is a factor, 2 is a factor, x is a factor, 4 is a factor. Lots of ways I can partially factor, but usually there is a way to get all the way down. So notice how here the farthest I could factor was 2 times 3 times 3. And here the farthest I could factor was 2 times 2 times 2 times x times x. There is a point where we can't factor something. You can only factor down as far as possible. So we've gotten to that for both of those. All right, the last example I want to go over here is 5 times a to the third times b squared. If I want to factor that as far as possible, well, it's going to have a 5. 5 is prime times an a times an a. There's 3 a's altogether, and there's 2 b's altogether. So there, I've factored it out. I've broken it down into its most basic factors all multiplied together. But from there, I can put it back together again, okay? What if I want to factor it into 3 things? Well, I could say it's 5 times a is 1 factor times an a to the b. Let's do a squared to 1b. That's another factor. Times one more factor, one more b. That is one way to factor my original expression into 3 different factors. All right, well, hopefully that helps you give an idea of what a factor is, working with some numbers and algebraic expressions, and thinking about breaking something into smaller components all multiplied together. And we can partially factor. I can factor as little or as far as I want, but as shown in like the example in the green, there is a point where you can factor something down and you can't go any further. All right, stay tuned in the following videos. We're going to start applying our understanding of factoring to working with binomials, monomials, and trinomials, and even some polynomials with 4 terms. So it's going to be good. Hopefully this helps get you a good solid understanding of how to factor polynomials, and stick with us for following videos.